and we have seen the example of this four quadrant operation of DC drive. So the chopper can help us generating positive negative torque and positive negative speed. That means anti-clockwise and clockwise rotation. So as I told you, anti-clockwise rotation is taken as positive direction speed, and clockwise rotation is taken as negative direction speed. So all these things are possible. Now we have seen the class A chopper here. The motor was rotating in the same direction. Now let us see. So this is a link for whatever things you have just seen that video. This link will be uploaded in Google Classroom also. You can check it on YouTube. Now see two-quadrant control of forward motoring and regenerative braking. So regenerative braking is actually the second quadrant operation. That means vehicle is coming down through a slope. So just now you have seen a video. Second quadrant operation, vehicle is coming down through a slope, its torque is negative, and the speed is in the positive direction. So at the time we have experienced that whenever the vehicle is in the slope and coming down, so we are always trying to put some brake, and that brake actually is converted to some kind of regeneration of energy, which is fed back to the supply. So how this thing is happening, here this is the second circuit of the chopper, which is called as two-quadrant control of forward motoring and regenerative braking through chopper. So class A chopper is single direction, but this two-quadrant is having bi-quadrant operation, and this is also controlled by chopper. So here the motor is M, and a two-quadrant operation means forward motoring and forward braking. That is first and second quadrant. It requires a chopper capable of giving a positive voltage and current in either direction. Okay, so motor might rotate in the positive negative direction, torque can be generated in the positive negative direction, both the things are required. This two-quadrant operation can be realized with a single chopper and reverse switch. So reverse switch is something which is new for you. So in this case, this R and S, this is called as a reverse switch. So initially, what we are finding is the C is a manual switch and the S is a transistor based switch, or you can say MOS based switch. So this is S is an electronically controlled switch and the C is a manually controlled switch. What is this coil? This coil is a field coil which generates field magnet. So this requires a supply. So this is a separately excited motor. Armature is getting supply from V through the C. So when C is closed, this supply voltage V is connected through C. C is closed through A, through R point, through S point, B, and the switch, and it is going to the ground. So this is, I'll tell you. So initially what happens is, as given in the right side in the top column, you can find we are at the initial stage of the chopper action. So how the two-quadrant operation takes place, we are explaining. There are mainly three steps. Okay, we'll explain that thing. So the chopper circuit uses S. So this is the S with IC. IC is the control current, which is controlling the gate. So that is 0 to delta T, that part. So the chopper circuit uses S with IC as a self-commutated semiconductor switch operated periodically. So 0 to delta T is the duty cycle, and delta T to T is the off time or freewheeling time. Switch remains closed for a duration of delta T. That is, this S switch is closed for delta T and remains open for 1 minus delta whole into T duration. C is a manual switch which is connected, and when C is connected, this B is directly supplying the armature. So field is already there, and there this A point is connected to R and B point is connected to S, and we can interchange S. So S can be connected to left side or S can go to right side. That means which direction of the motor is to be positive, which direction to be negative, this we can interchange by means of the RS switch. This is a reverse switch. So next, see what is the step 1. So there are 3 steps that you have to explain. Step 1, C is closed. So this is the first step. There is nothing difficult to understand in this case. C is closed, so this supply V, which is flowing through C, and in this case S is also closed, so IC has closed the switch S. So initially the V is connected to C through A, through R, through armature, left side positive, right side negative, through S, B, and through S is comes to the ground. So this is the first case. This case is called as forward motoring operation. Now A terminal is positive and B terminal is negative. What is the next case? Next case, C is open. Okay, so motor is running with a very high speed, inductor is having huge amount of current. Suddenly what we do is, as we did in the case of first chopper A, suddenly we are cutting the supply from the armature of the motor. What happens? Again, the same thing. Huge amount of voltage is produced in the reverse direction of the motor. So C is opened. The regenerative braking in the forward direction occurs now. So what is regenerative braking? Torque is produced in the negative direction. Okay, that is what we have found. That means we are stopping the motor to run in the forward direction with the full throttle. What we have done is we have removed the supply, so the forward direction speed will decrease slowly. That is what is the step 2. So C is opened, regenerative braking in the forward direction occurs because the forward direction torque is reducing. Now the armature connection is reversed. So R is taken to the right and S is taken to the left. So in this case, by the using reversing switch RS, the RS terminals are inverted or interchanged. It makes terminal B, which comes in the left side, as positive, and terminal A, which comes in the right side, as negative. That means R and S we are interchanging after we are opening the switch C. So two steps are there in the second step. First step is open C. As soon as you open C, the supply voltage is not connected to the motor anymore. And second step, interchange R and S. If you are doing that, in that case, the motor direction of rotation is being reversed. So there is a second step. Second step continues here. In this case, as long as the switch S is on, so second step is having two parts. First case, C is opened and S is connected. S is still connected. And second step is explained here. Okay, so in the first case, what happens? C is opened and S is still connected. In that case, this bottom loop. Okay, so as long as the switch S is on, C is open but S is on, that means S is connected. As long as the S is on, motor current flows through the path consisting of motor armature, switch S and diode D1. You can see this diode D1 is bottom positive. So this thing will keep on circulating because this point was positive. And what is this diode D1? This is that flywheel diode. Okay, now suddenly as we have cut the supply from this motor, as is an inductor, there will be produced a voltage in the reverse direction. That means this point right side will be positive and left side will be negative. That means in that case, that huge amount of Lentz's law voltage, reverse direction voltage, will make the D1 forward pass, and there will be circulating current flowing through the motor, this switch and diode D1, as long as this S is conducting, or S is in the conducting stage. So this is step 2. Last is step 3, which is the regeneration stage. Now what happens is, after the circulating current is gone, now the switch S is now opened because the time 0 to delta t is gone. Now the whole circuit has entered in the delta t to t, that is the freewheeling region. In this case, the switch S is now opened. So C is open from the beginning, S is open. Now what will happen is, whatever is the negative voltage, because this one was positive, this negative voltage now will flow through D2 to supply voltage through D1 and come back to the motor. So switch S is now open. The current now flows through the armature diode D2. So to make armature diode D2, this point, which is R now, okay, this should be positive. Why this is positive? Because sudden opening of C has created a negative voltage across the motor. That's why this right side point is positive, left side point is negative. This right side point will make the D2 forward pass. So as soon as the switch S is open, the current now flows to the armature diode D2, supply V, diode D1, and again it will come back to armature and it feeds the energy into the supply. This is called as regeneration. So I told you long back that how the braking is producing regeneration. So there are two things. One is braking. Braking means we have cut the supply from the motor. That means we are asking the motor to generate a torque in the negative direction, and at the same time, whatever is the uh, uh, current produced or voltage produced because of sudden open of C, that extra voltage is getting added to the supply, and this is actually called as regenerative. So braking is occurring, and at the same time it is giving back some supply to the some voltage to the supply. So this is called second quadrant operation. This is called regeneration. So the motoring to regeneration changeover is done by using the following step. So the whole third step is explained in elaborate manner. So switch S is deactivated and switch C is opened. So there is a third case which is again being explained. So this forces the armature current to flow through the diode D2. Because of Lenz's law, there has produced a negative voltage. So this negative voltage will make actually the diode D2 through flow. So D2, source V, and D1. The energy stored in the armature circuit, or actually armature coil, is fed back to the source. Okay, and the armature current falls to zero. So it will happen how long? As long as the negative voltage, whichever is created because of sudden opening of C, as long as that voltage is high, as long as that voltage is keeping the D2 and D1 short circuited, that long time, or for that much time, this regenerative voltage will keep on getting added with the supply V. So the energy stored in the armature circuit is fed back to the source, and the armature current falls to zero. So slowly this voltage will diminish and the current will becoming zero. So after an adequate delay to ensure that the current has indeed become zero, the armature correction is reversed. So again, right side was R, left side was S. Again, it will be reversed R and S. And in the next step, the armature connection is reversed. Switch S is reactivated. So 0 to delta T is again started in the next cycle, and the suitable value of delta to start the regeneration. And next step is C is connected again. So there are three steps. In the first step, C is connected, forward motoring. AC is already connected. Second step, C is open. Okay, AC is connected. So suddenly C is open means there is a huge amount of voltage which is produced in this right side and left side, and this RS switch is reversed. Okay, so in this case, there is a second stage where C is open but AC is connected. In the third case, what's happening is C is open and S enters a freewheeling zone or open zone. In that case, the motor, diode D2, supply, and D1 all are actually in a conducting stage, and this is called as reverse current or regeneration, or this is called as a regeneration second quadrant operation. So these two slides have to be explained very properly if two quadrant operations are asked. And in that case, you have to draw actually two diagrams. In the first diagram, step 1, R should be in the left side and S should be in the right side. And in the step 2 and 3, after you have reversed the R and S, so whenever you are drawing the circuit diagram, same circuit diagram, so in the case 2 and 3, C will be open, S will be open. Please show the S in the left side and R in the right side. And at the end of step 3, again R is put in the left side and S in the right side. C is open, S is just closed, and it is on the verge of starting again. So this is a two quadrant control of forward motoring and